All right. So, okay. So thank you very much, guys. So I'm without wasting any time, I am going to start my session. So today's session is basically seismic attribute analysis. All right. So this is basically the technique from where we can explore hydrocarbons within a subsurface. Actually, if before going to start, I am going to show you some images. If you are basically see any, if you have any data set related with 2D seismic or 3D seismic, or you can say that the 4D seismic, then you can see such type of seismic sections, all right, where you can see the highest value of seismic amplitude as well as the low values of seismic amplitude. For example, let's suppose in this image you can see the highest value of seismic amplitude, which is basically red in color, while the lowest value of amplitude is basically black in color. All right, so it is basically red and black. You can say that the seismic section. You can simply interpret your data set. You can simply mark your faults. You can simply identify your structures, and after that, on the basis of your reservoir maps, all right, you can find a lead. All right, and after different studies, you will carry out petrophysical studies, geomechanical studies, and much more thing. And after that, you will decide that from where you are going to interested in order to mark the well location of on your surface location of the earth. But in that case, this is basically the conventional seismic data interpretation. If you are interested in order to critically view your data set, then you must jump to your seismic studies, or you can say that the seismic, you will must do the seismic attribute analysis. So what is basically the seismic attribute analysis? So I'm going to, in today's session, I am going to explain right to, you can say that because this one is 1 hour, only 1 hour session. So I am going to wrap my session very quickly, and I will try to summarize my lecture in 1 hour. So now I'm going to start that what is basically the seismic attribute analysis. All right. So basically, seismic attributes are the components of seismic data. If you have seismic data set, then these attributes are basically the subcomponent of your seismic digital data set. And this can be obtained by different mathematical processes, all right, which includes the computation, all right, and it is basically these things were firstly introduced in 1970s. So at that time they were known as DHI, basically seismic attribute analysis. If you are going to study all these things, these are basically within that study we have a small part which is known as DHIs. So DHIs are stand for direct hydrocarbons indicator. But in early 70s they were going to many people name it that these are not direct hydrocarbons indicator, but these things are basically the dry hole indicator, because at that time this technology, because after 70s seismic methods are common in oil and gas industry, and with the help of seismic method there are many companies explore different high reservoirs and high health reservoirs in different region on the surface location of earth. But in early 70s, because this one is seismic was basically the new technology, so in that case we have the seismic attribute. But the thing is, at that time these are basically known as dry hole indicator, because many wells were drilled with the help of seismic attribute study, and all wells mostly well going to at that time dry wells were there. So in nowadays, during this technology in this era, All right, so with the help of seismic attributes, we can study different hidden geological features, stratigraphic features within our subsurface reservoirs. How we will see in our next slides. Basically, these are basically the mathematical thing, all right, and these attributes are basically the commercial interest, all right, which is used in order to explore, you can say that, the hidden feature of the subsurface earth. So what are basically the seismic attributes? So I am again closing my presentation and jump to my, you can say that, images. So these are basically the conventional seismic section. You can see here the different variation in color, and these variations are due to density contrast. So these densities are basically, you can say that, the difference in between the acoustic impedance of above and below lithology. So therefore we can see the color variation within our data set. But in that case, if I am going to critically visualize my data set, then we have three type of seismic traces. So one is conventional trace, which is also known as the real trace, which is basically the red one you can see there, all right. Now the second one is basically lies in the second dimension, which is basically the imaginary trace, all right, which can be calculated with the help of different mathematical processes. And after that, we have another trace which is basically known as complex trace, all right. So I am going to visualize my data set, which is basically a simple color variation for a common person, all right. But if I am going to show you, you can see that the background of these seismic traces, then each seismic trace represent the each the complex trace, real trace, as well as complex, you can say that the imaginary and complex trace. So within these traces, there are basically the hidden information there, all right? Hidden informations are there, and these hidden information can be extracted with the help of frequency, with the help of wavelength, with the help of phase, with the help of, you can say that, the time, with the help of frequency. So all these are basically the sub part of seismic attribute. So with the help of these hidden features, all right, we can extract a critical information, sensitive information from our data set. Because in that seismic, in conventional seismic data set, I cannot even see anything in my, you can say that, in my data set. But if the things that you cannot visualize with the help of your naked eye, and you will use different mathematical processes and extract the information, are basically known as seismic attributes. So nowadays, the seismic attributes are basically the most advanced technology. With the help of seismic attribute analysis, you can extract the TOC, total organic component information, from your data set. So now there are basically two main types of seismic attributes. The first one is basically the physical attributes, and the second one is geometrical attributes. All right. So you have two type of stacks of your seismic data. So what is basically the stacks? So stacks are basically the gathered information of your field seismic data set. All right. When we collectively stacked, or you can say that, sum of all, sum your data set, all right, then it is basically known as one stack, all right. So we have two type of attributes there, the physical attributes and geometrical attributes. So we can apply the seismic attribute analysis on the pre-stack dataset and post-stack dataset. So there is basically the attribute which is known as AVO, all right. So AVO study is basically carried out in a pre-stack information, all right, or you can say that the pre-stack dataset. And remember, these information is only applicable, or you can say that the mostly applicable in 3D seismic dataset, because on 3D seismic dataset we have a control on our dataset. We can visualize different cross sections, all right, and which give us the information of our real subsurface earth. So the physical attribute are basically the directly related to the wave propagation, all right, lithology, and other parameters, all right? And these physical attributes can be further classified as pre-stack as well as the post-stack. And we have again a subclasses which include the instantaneous wavelet attributes and much more. We will see each and everything in different images. Now, the second type of geometrical attributes are basically the dip, azimuth, discontinuities, all right, which shows the variation of the subsurface, all right, which also shows the top view of your subsurface reservoirs and discontinuous features, just like the fractures, which cannot be visualized with the help of your naked eye, all right. So these are basically the attributes that are basically two types, all right. So in a post-stack seismic attributes, we have the information which is basically known as bright spots. We can also detect the gas accumulation with the help of post-stack seismic attributes. We can easily distinguish between the sequence boundaries, which is basically related with stratigraphic information, which shows the depositional environments, all right. We can also extract the thin band, all right, with the help of tuning effect phenomena, all right, because seismic is not in high in quality, all right. So with the help of many features can be missed if you require the seismic data set, all right, many features will be missed, all right. But if you are going to jump and study the seismic attributes, which are basically the frequency, phase, polarity, and much more, so you can detect a lot of information where you cannot see with the help of your naked eye in your or you can say that your conventional seismic sections, all right. Also, you can study the lithological changes and local changes, which are basically the faults, also the fractures, all right. So the fault, which is very small throw, cannot be seen in, you can see that in your seismic sections or your seismic data set, all right. If you're talking about the fractures, so you cannot easily detect the information of fractures from your data set, so you will must jump to the attributes, and the attributes includes the geometrical one and the physical one, also the subdivision. So it is up to you that how you are going to, what is basically your target, and how you are going to use and detect different type of information. Now we have two type of seismic section. There's the above one and the below one. So above one is basically, you can see that the normal you can say that the coherency attribute is there. This one is known as coherency attribute, which shows the density variation within your data set. You can see that the blue in color, red in color, while red color representing the highest amplitude, right, or high amplitude values, while the blue color represent the minimum values of your amplitude, all right. So if I convert my data set to a specific seismic attribute, then you can see and detect the information which is basically related with high amplitude values, all right. So these basically software automatically subtracted all other information and shows you only highest amplitude values with the help of different mathematical processes, all right. So this is how we are going to extract the information from our data set. So I am we have also the course which is basically the Petal software. So within a Petal software, I am going to show you that how we can apply the seismic attributes on 2D seismic data set. Also, how we are going to apply the seismic attribute studies and show you that how these lithologies are basically differ from upper side as well as if you are talking about the lower side of your reservoir zones. All right. So here I'm going to mention the first thing that is basically the instantaneous phase. All right. Phase is basically the angle. All right. Now, much more phase attributes are there, just like cosine of phase, all right, just like instantaneous phase. All right, so depending upon on your objectives, goals, and your data set, you can apply a specific attribute you, and you can extract the information. For example, if you're working near the Himalayas or fold and thrust belt, and if you have 2D seismic data set, then only one attribute is applicable, which is basically known as cosine of phase. So cosine of phase attribute enhance the amplitude, and you can easily interpret your data set even if you don't see any kind of amplitude in your seismic data. So with the help of instantaneous phase, all right, we can extract the information, and which is also you can say that the indicator of lateral continuity, right? The bed is basically you can say that if you are talking about the subsurface bed, so if you can't see the seismic amplitude or continuity of your subsurface reservoirs, so you can apply the instantaneous phase, and with the help of instantaneous phase, you can easily you can say that they study your subsurface reservoirs, all right? Also, it relates to the phase component of the wave propagation and can be used to compute the phase velocity, all right? So many, these are basically the thing that phase is basically do in order to study the continuation of your subsurface reservoir. So it enhances the amplitude, and you can see that you can easily show the different lateral variation within a subsurface, all right? So also, if it is basically the lateral continuity attribute, so it is also very applicable if you are talking about, and if you are doing the sequence stratigraphic information, because in that interpretation we must know the boundaries of our sequence. So for that case, if you have low quality of your data set, even good quality of your data set, so this attribute can enhance these stratigraphic features, all right? So the second one is okay, all right, so you can see that this one is basically the instantaneous phase. You can see the seismic amplitude, while within the next image at the right side, the instantaneous phase is now applied, and you can see the lateral continuity. You can see the black lines, which is basically the you can easily distinguish your continuity of your subsurface reservoir. So within that, you can see there low quality of data set is there, right? So you cannot even see the information there. And this is basically the cross section, all right? This one is basically the cross section. The instantaneous phase is applied on the cross section, not on a, you can say that the surface, all right? 2D surface or 3D surface, all right? So this one is basically the cross section. Now, the second thing is basically the instantaneous frequency, which is also very, very important if you have a thin bed, all right? Because seismic data miss such type of feature, all right? So for bed thickness, if you have very low quality or resolution of your data set, all right? For the two type of seismic sections are there, low frequency data set are there, and the high frequency data set are there. If I am talking about the low frequency data set, then in that case, you can see your subsurface beds very thick because frequency is too much high. But I am going to show you in images. If I am going to Google this information, that is basically low frequency seismic section. All right. Okay, so low frequency is basically representing the thick bands, all right. But actually, within a subsurface, all right, we have no thick bands. Just like that, you can see there. You can see this type of image. So this one is basically the low frequency data set, all right. The beds are very thick, all right. So this is basically the if the frequency is very high low, then it means you are missing too much things within that information. So we apply instantaneous frequency in order to detect thick bed. If you have high frequency data set, so high frequency data set is just like that, you can see there, all right. So high frequencies are representing the thin beds, all right. But the problem is when we do the seismic survey, then the high frequency absorb within a subsurface. So within seismic data processing, we are interested to reintroduce the high frequencies, all right. So for that purpose, many of high frequencies are going to be missed. So during seismic data interpretation after processing, we use the technology which is basically known as seismic attributes, and frequency is a subpart of seismic attribute. So with the help of frequency attribute, we can detect the thin bands from our dataset. All right. So it is also indicator of fracture zone. If there are fractures, so we can detect the fractures with the help of frequencies. All right, because higher frequency indicate the sharp interfaces and thin shell, all right. Because if there is a high frequency data set, then you have a lot of information, but if you have low frequency data set, then it means you are missing too much things. So it is very useful if you have basically in order to study the bed thickness, all right. So this attribute is very good in order to study each and everything. So you can see that this one is the cross section, and when we applied same attribute, that is instantaneous frequency attribute, on that section, then you can see that the instantaneous frequency is basically uh, you can see that the thin bands are there, all right. So this we can easily detect the information which are basically, you can see that the thin bands are there and you can easily extract the information, all right. But this one is basically the cross section, all right. Okay. Now, so I have mentioned only two attribute due to time limitation. All right. So we have different geometrical attribute that are basically the dip attributes, azimuth attribute, and discontinuity attribute. All right. So the dip amplitude, or it is also known as the amplitude of the data, correspond to the dip seismic events. It basically indicates the dipping factor of your seismic data set. All right, that how your lithologies and the subsurface structures are dipping. Also, for azimuthal attribute of your amplitude is basically representing the maximum dip direction of your seismic features, right? And the discontinuity attributes is basically related with faults, small faults, or you can say that the small fractures, all right. So the first one is basically the discontinuous attribute. So now this one is surface, all right. So here is prayer time, all right. So we are going to take a short break. So just after 2 or 3 minutes, all right. So I'm going to uh, restart my session. All right. Show you that what is basically the surfaces. All right. So this one at the left side, you can see here the seismic data set. All right. So we have opened the surface. All right. At some interval. For example, if I'm talking about the reservoir interval, so I have just opened the reservoir interval, the surface on my, you can see that the time surface or depth surface in a software. All right. Now at the right side, you can see here the different attribute, and this attribute is basically the discontinuous attribute, which is basically representing the small false feature. So now in the right side, you cannot extract the information. All right. You can just see the blue color and the red color and the dim colors, while in the right side, when software applied a different mathematical process and extract the information which are basically related with discontinuous attribute, then the software is basically show me such type of feature which is basically the continuation of the fault zone. All right. So you can see the fault is just like this. You can see that the fault lines. All right. So this one is basically the azimuthal view of your fault, which is basically representing the striking component of your subsurface fault. So with the help, because these faults or fractures are very important in order to extract the hydrocarbons, because faults or fractures behave as a barrier. All right. If you are going to ignore these features, so you will, your well will become dry. Therefore, in early 90s, your many of wells drilled with on the basis of seismic attributes were completely dry, and also DHIs were known as dry hole indicators. So this is how we are going to extract the information. So this is the real one. So the real method in order to extract the information from your seismic data set. Now, but the condition is you have 3D seismic data set. If you have 2D, you can't do this type of things. All right. So, for example, if we are going to consider some caves study of a block of alpha 3D, which is almost 100 square kilometer. All right, and it is basically the pre-stack time migration volume. All right. So now we are going to study that. This one is basically, for example, reservoir, XYZ reservoir, and this one is my reservoir map, all right? You can see there where you can see there the highest values, all right, and also the lowest values, all right? So you can see there, all right. So now again we have another block which is basically the beta 3D, which lies here. You can see there. Now you can see the different seismic sections with your interpreted seismic sections are there. Also we have the interpreted faults, all right, you can see there. Now this one is basically my data set, which is also known as the volume of my data set, all right. So this one is basically the 3D volume, is basically representing your 3D data set, all right. So this one is basically the surface, this time surface of the depth, or you can say that the depth surface of your volume, all right. So now I'm going to show you another attribute which is also known as the curvature attribute, which is basically representing the undulation of your surface, undulation of your subsurface structures, all right. So on the basis of seismic section we cannot extract such type of information, but when I open my volume on my reservoir interval, then I am going to visualize such type of red lines, which are basically same like the blood veins, all right. And these are basically your fault, your subsurface structure. That your subsurface structure is, for example, the upper side is north. So this one is basically the feature where your fault is basically towards are basically moving towards north, and on that location it is bending, all right, and then it is again moved towards northeast, and again it is bending, and again it is bending, all right. So this is basically known as curvature attribute, which basically shows you the real picture of your undulation within a subsurface, or you can say that the striking component of your subsurface structure, all right, that how your fault is basically going to move on the north side or south side, or because all these things are very important. If you ignore these hidden information, all right, then your valve will become too dry, because within a subsurface we have nature forces that are basically the compression forces or extension forces. So if you ignore all these forces, all right, then your valve you cannot do even drilling, all right. Because why we are going to do reservoir geomechanical studies, all right, because we are going to study the subsurface forces. When you are going to study these subsurface forces and include in your data set, then it means that you are basically targeting your reservoir or target your reservoir zone in very safe and sound way, all right. So if you are going to ignore all these things, that it means then too much forces are there, you are facing too much difficulty during drilling, and even you cannot reach up to your target. So all these things are very important in order to consider within, you can say that, the data set, right. So in that case, you can see that we have a monoclinal structure is there. So if you have monoclinal structure, then how we are going to use in the curvature attribute? So we have a surface map. So for example, this one is my reservoir zone. The back side is my basically seismic section. This one is reservoirs, my reservoir zone. So when I am going to extract the slice, the time slice of that zone, then I will get such type of feature where you can see that how your basically structure is going to, or you can say that the trending towards north, towards east, south, or in all direction. So this is how we are going to study the seismic attributes. All right. Now, mostly you can see that the positive because we have too much things in seismic attributes. So I'm not mentioning each and everything. All right, because due to time limitation, I'm just giving you an overview that how the seismic attributes are going to work and how we can gather information, hidden information from our seismic data set, right? So we have a type of curvature attribute which is also known as the positive one, all right? So it is basically taken the at now 1980 milliseconds, all right, from beta 3D cube. You can see there. So 1980 millisecond means that this one is basically the time slice, all right? So time slice, I'm working on a time slice, and with the help of curvature attribute, I can extract the information, which is we can see the shear zone there, we can see the force there, small force are there, and how it's trending we can see with the help of such type of attribute. If you have only common simple data set, whatever it is 3D or most advanced data set, and you have don't, if you don't carry out such type of study, then you will ignore all these things, and at the end you will get a dry hole. All right. Now, the most common attribute are basically the coherency attribute. So with the help of coherency attribute, it shows the density variations, all right, acoustic impedance variation, because each lithology is basically deposited in a specific interval of time with a specific grain size, and different minerals are there. So each have basically the you can say that density contrast. So due to density contrast, so we have heterogeneity material. So due to heterogeneity material, we can see the highest values amplitude from our data set, and we can extract simple information with our from our data set. All right. So this one is basically the coherency attribute. You can see there very beautiful seismic amplitude are there that are basically red in color and blue in color, which is basically representing the coherency attribute, all right, which is basically representing the highest value of attribute as well as the lowest value of attribute. Now, in that case, the color table is there. So the red color is basically the lowest amplitude, all right, while the highest colors are basically, you can see that the blue color is representing the highest value of your seismic amplitude. All right. So this one is basically the slice, all right. So with the help of slice, you can see that where the highest amplitudes are and where the lowest amplitude are, because on the basis of higher amplitude we can study the different features. Just like that, I am going to show you that for example, if you have a seismic section, so we have a multiple seismic traces. So we have different type of seismic traces. If you are seeing the simple traces, then it is mean that you are only see the amplitude trace amplitude, you are going to study only seismic amplitude. That is basically representing of coherency attribute. Then we have another feature just like that. So with the help of such type of features can be detected with the help of instantaneous frequency, phase, envelope, and different type of attribute, and we can get and extract the information from our data set. So we have a most common attribute analysis, all right, which is basically known as the pre-stack seismic attribute. And this pre-stack seismic attributes are all known as AVO. AVO stands for amplitude versus offset. It is basically just like if you are sitting at the bank of the river, pond, or water body, and you are going to throw a water stone or pebble, all right, in a water body, then what will be happen? The seismic waves, or you can say that the waves will be generated, and these waves are basically high in amplitude when it start, and at the end when it going to expand, then this amplitude are decreasing. So same cases in seismic studies, all right. So we have different classes there: class 1, class 2, class 3, and class 4. So with the help of class 1, if I am going to basically study all these are basically representing of dim spot, bright spot, flat spots, all right. So on the basis of all these spots, we can extract the hydrocarbons, hydrocarbon zone, gas zone, water zone, with the help of from our you can say that if you have only seismic section, you can easily detect all type of features with the help of seismic data set. All right, even if you don't have any web. All right, so therefore these are basically the latest technologies in order to do each and every. In class 1, the amplitude is basically, initially we have high amplitude, and at the end the amplitude is decreasing. You can see that, and you can see in the synthetic the wave amplitude at initially we have high amplitude, and then which is also basically known as the dim store. These are basically not a bright store spots, these are basically the dim spots. All right, now we have second class. So in second class we have a bright spot, and these bright spots are basically start from the lowest value of amplitude, and at the end we will get the highest value of amplitude, which is basically representing the high, basically the high events, high amplitude events, also known as basically the bright spots. All right, and in that case the acoustic impedance difference is very very low. Now we have class 3. All right, so class 3 is also the highest amplitude and also increasing further and further. All right, so if you were talking about, so we have two diagrams there in every image, so which is basically just you can say that the color variation, initially we have the lowest amplitude, this one is blue, one is the lowest amplitude, while in another case we have a high amplitude. All right, which is basically the red one. And if you were talking about flip the colors. All right, now if you we have the class 4. In the class 4 the acoustic impedance is very different. So due to difference, these are basically starts with high amplitude and then it decrease. The class 4 and the class 1 is same, but the problem is that we have only polarity reversal from class 1 to class 4. All right, so this is how we are going to study the acoustic impedance. Further, we have a huge studies there. All right, uh, there is a paper, I think, if I have. All right, so with the help of paper you can extract different information and to collect the information that how all these things going to be work in you can say that in you can say, but without software you cannot do these things, because these are basically the mathematical processes. All right, okay, so I'm going to show you the images. All right, okay, I think this image is good, but all right, okay, where is the image? Uh-huh. All right, so this image is very small, so therefore I think very difficult to visualize, but you can focus on that. So with the help of, you can see that with the help of this seismic amplitude studies, we can detect the information of the flat spot, dim spot, and the bright spot, and we can easily distinguish because hydrocarbons, water zone there, gas zone there. But this one is basically a totally practical thing, and these things are basically the experience. It requires experience so that you can extract such type of features, such type of things from your data set. So we have flat spots there. All right, from there to there the phase is changing. All right, so and at the bottom you can see here the bright spots. All right, so on the basis of all these things and different studies, when we will carry it out, then we can easily distinguish in between the sands body, water sands body, the gas sands body, and the oil sands body. So this is how we are going to study each and everything with the help of different seismic attributes. All right, so we have coherency attribute. attribute as well as curvature attribute. So with the help of curvature and currency, you can compare these two values and mathematical processes. So with the help of, we have original seismic attribute there, and this one is basically currency attribute, right? So this one is basically the currency attribute, from where you can see your information is there, all right, the subsurface structures, or you can say that the top view of your subsurface uh, uh, faults, and the things are small faults are there, all right. While in that case, if you are talking about the positive curvature, all right, versus coherence attribute, so this one is basically the curvature attribute, and this one is currency attribute, right? So from there to there, you can compare all these two values, and you can check the hidden information. And remember, these are the slices, not the cross sections, all right. So you can also see comparison of two attributes, which are basically the currency and the most positive curvature attribute, and the time slice at that beta 3 cube is 2500 milliseconds. So there is a fault, you can see in the cross section, all right. So with the help of most positive curvature attribute and the most positive currency attribute, so if I am going to compare these two attributes, then the curvature attribute is most authentic as compared to currency attribute, because some disturbance are there, you cannot see due to high and low values of your amplitude, but in that case you can see the smooth single line which indicates a fault, or fault which have a very small throat, all right. So you can see there difference in between the curvature as well as currency attributes. So both are applicable. Sometimes we will use currency, sometimes we will use curvature, sometimes currency shows the better resolution, sometimes curvature shows the better resolution, all right. Okay, again you can see there, if you are talking about we have a salt body or any homogeneous material is there, therefore you cannot even see the data set. But in that case, at the bottom right side, in that case, if you are taking the attribute that is basically the most curvature attribute, so in that case you cannot see information, all right, no information is there. But when you apply currency attribute on the same, you can see that the block that is basically the alpha 3D, and the time slice is 200 millisecond. So you can see the information, all right. You can see the information. Therefore, sometimes we will use the currency attribute, and sometimes we will use you can say that the most curvature, or you can say that the positive curvature attribute or negative curvature attribute. So now these are basically the conclusion of these slides, that before extracting seismic attribute, seismic 3D volume should be analyzed in detail in terms of data acquisition and processing. Data quality is very necessary. If you have low quality of your data set, you cannot easily detect all these information from your data set, all right. So if you are taking the example of curvature and coherency attributes, so these are basically the powerful tools in order to extract the information of a hidden feature, just like small faults or fractures, all right. And with the help of these faults and fractures, and mostly sometimes we will use the curvature and sometimes we will use coherence, means that we are going to utilize these two attributes side by side, all right. Also, in case of seismic tubes with good signal noise ratio, means that if you have a good quality of seismic attributes, then these currency and the curvature attributes can effectively differentiate between low and high angle faults, all right. But the condition is that if you have good quality of your seismic data set. If you have poor quality of data set, all right, I am talking about the 3D seismic data set. If you have poor quality, then you cannot do all these things, all right. So based on all usefulness and discontinuity attributes discussed in this presentation, they're used along with the seismic attribute, all right. So this was our presentation, that how these seismic attributes going to be work, all right. So I have a research paper, and I prefer you guys to read this research paper, all right. So I'm going to share uh All right, I'm going to share you in chat box. Yes, this is the paper. So so I am going to share this paper with you guys, so I suggest you to read this paper. So all attributes, mostly attributes, are mentioned in that paper, and you can easily distinguish all these things with the help of you can say that different attributes. All right. So now I am going to take questions. All right. So the first question is that how much important is seismic in geophysics nowadays? All right. Without seismic, you can, geophysics is empty. Without the seismic, you cannot do the seismic data. You can say that you can't do the oil exploration. So seismic is the technique in order to delineate your subsurface. You can say that the reservoir. So without seismic, petroleum geophysics is empty. The next question is that what is acoustic impedance? Acoustic impedance is basically the product of density and velocity. If you have a density information, if you have a velocity information, then you will get a quantity which is known as acoustic impedance. So with the help of acoustic impedance, you can visualize your data set. So this is how it is important when you are going to study all these things. All right, so the next question is basically how to take the slide, how to take slice attributes in deep structure. Is it possible to flat reflector or not? Or I know the condition is if you are going to take a slice, not because in the real earth is not a flat. All right, you can see the undulation there, you can see different geological features there. So you can just, with the help of software, you can just extract this type of information. All right, so I can't do these things in this workshop because I don't have any software. All right, but we have a separate course that is basically the better software training, which is almost 7 days course. All right, so it is mentioned in detail that how we are going to extract such type of information if you are going to use any type of software. All right, the next question here, what is meant by a low frequency data set and what does it signify? Low frequency data set means I am going to use the paint, all right, the paint software as a blackboard, or sorry, whiteboard. All right, so I'm going to open this one. So we have two type of data set. We have initially the seismic traces. All right, so combination of seismic traces make the seismic sections. All right, for example, if you have an information, all right, so this one is basically, all right, so this one is basically your seismic trace. All right, so we have amplitude there, right? But if your amplitude is too much, this thing, and if you have a seismic trace which have same amplitude, my drawing is not good, but same amplitude, just like that, all right, then you have two type of data set. This one is high frequency data set, while this one is low frequency data set. So if you have low frequency data set, then you see your reflector are very thick. But in that case, you will see that your reflectors are very thin. Amplitude is same. But in that case, thin reflectors, but in that case, thick reflectors, all right? So due to thick reflectors, these informations are missing. Therefore, this data set is basically poor quality data set, while this data set is high quality data set. So I prefer high data frequency data set because we can extract more and more information with the help of high frequencies. While if you are using low frequency data set, then it means that you are missing too much things within your data set or within the subsurface. So this is how the low frequency data set and the high frequency data set are going to work. Now the second is, what is better method in surface attributes and is the better than time slice? It is depending upon on your objective that how you are going to extract the information. If you are extracting the sequence stratigraphic information, then you will use separate attribute. If you are going to extract another, your objective is change, that you are doing structural interpretation, you are searching the thin beds, or you can say that the thin you can say that the small faults with very very low throw, so you will jump to another. So it is basically the thing that you will must remember on your fingertip, that I am going to accept, I am doing sequence stratigraphic information, then I will use such type of attribute. If you are going to extract the thin beds, then you will use X attribute. If you are going to extract interested in order to study the small faults or right or fractures, then you will use Y attribute. So all things will be remember on your fingertip, that how you are going to, all methods are good, all right. The thing is that you must operate the software, you can handle software, and you can extract all this information, that how you are going to extract all these things, all right. The next question is, the most important is the workflow for each attribute. Yes. If there is any material, or yes, the workflow is very important. All right. So this was just 1 hour overview, not a detailed course. All right. So the thing is that the workflow and your objective is very important thing. All right. So on the basis of your objectives, target, so you will design a workflow, and then you will get and extract the information from your data set. All right. Is there any attributes? The next question is to minimize the salt pull up effect. Yes, there are many attributes in order to extract the salt information. But if you are going to minimize salt pull up, then it means that you are not sincere with your data set. You are ignoring salt information within a subsurface, right? So if the salt is irritating, yes, salt is irritating thing. Salt is very difficult thing for seismic interpreter, mostly if you are working in fold and thrust belt in compression regime, all right? But you cannot ignore these things, because due to these things, you will be completely, you can say that, destroy your valve, all right? During drilling, you will face, if you ignore these pull-ups, then it means that you are basically ignoring such type of body. So these are basically because if there is a subsurface salt within a if the salt body is there within a subsurface, then during drilling, the most important thing and the difficult thing for drilling engineers are basically the salt body within a subsurface. The most important thing during seismic data processing is to extract and process that data if there is a salt body within a subsurface or mud volcano within, but mostly the salt body within a subsurface. Again, the most important thing and difficult thing for interpreters are if there are salt body within a subsurface. So you cannot, you can increase or decrease, but the better thing is to study your salt in very effective way. Yes, there are attributes that you can, with the help of when you apply the attribute, then it will maximize the effect. It will shows you the real picture of a subsurface salt. But if you are ignoring the salt, then it means that you are creating a big problem for you. All right. The next question is pre-stack. Pre-stack is basically when we have, if we, I have don't, you can say that my data set is not summarized. All right. No submission is done. All right. So it means that the pre-stack data, when you sum all of your data set, then it means that uh, this one is basically the post-stack data set. So I'm going to show you pre-stack seismic. Pre-stack seismic. All right. So this one is basically pre-stack seismic. Your data set is not summed up. All right. This one is your data set. or you can see that this one is your data set. When you sum up your data set, you will get only one seismic section, which is known as post-tax seismic section. So this one is your post-tax seismic sections. So this is how you can differentiate post-tax, and you can say that the you can say that the pre-stack. All right, the next question is how we can get the research paper. You can see I have already shared with you guys. The next question is how to do frequency AVO. All right, so I think I have clearly mentioned that how many types are there. For more information, I am also going to share, uh, I will at the end of this session I will going to share this slide that how all these frequency
Sorry guys, just wait for a minute. Sir will join again.
sorry for that, because I think something a problem. So you can extract the information and you can simply redesign, just like the color that the first one, the basic color is white one. This white color is divided into 7 colors. So with the help of 7 colors, if you mix different and variety of make a combination, then you will get a huge color, you can say that is scheme. All right, so just like attributes, so with the help of mixing of different attributes, you can get more and more information and extract more and more information from your data set. Yes, if you have any more question, you can simply rewrite again, because I have again joined this meeting session. So I am going to see no information is there. Uh, just a complete white no chat is there. So you can just simply send me the voice message, or you can send me the text message on my WhatsApp. I am going to share with you. If you have any problem, then you can simply contact me. So for now, I think I have mostly summarized my lecture. So this one is my WhatsApp. I am going to share with you guys. All right. So this one is my okay. Chat is disabled. I don't know why. So anyhow, all right. So I think everybody can see my number. So this one is my WhatsApp. So you can simply send me the WhatsApp message or voice message. All right. So I will thoroughly guide you and give you about the idea. If you are fixed, or if you are stuck in any problem. So thank you very much for now. Over to you, Nikhil.
Thank you so much, sir, and thank you so much, participant, for joining with us in this wonderful workshop. And if you have any queries, you can just send to us or send to sir. He will give back to you the answers. At last, thank you so much, sir. Have a good day, everyone.
All right. Thank you very much. Thank you. Have a
Thank
good
you.
night. Thank you.